Hey, it's winter break, and as I'm making this, it's actually the day we're having kind of a snowstorm outside. Too bad this doesn't happen when we're actually in school, right? I know, especially on the winter that wasn't. Okay, now today you actually have a notes sheet in front of you because there's certain things in a certain way I want you to write things down. And you're going to have to endure my little preachy moments here, having to deal with measurement systems and the United States, and yeah, yeah, you'll see. So the heading is 5-3 dimensional analysis, and this first part we're going to focus in on just the metric system. Okay, so you have studied the metric system probably for quite a while since you first started in school and doing some measurement. The metric system has been around for a long time. Okay, it was thought of hundreds of years ago. The beauty of it is that it's internationally recognized and agreed upon as a system of measurement. The easy part about it is it's based all on decimals, so it just makes it so much easier for converting. And it's actually been sanctioned to use in the United States for over 100 years. Actually, now since it's going to be 2016, 150 years. But we still don't use it for our primary system, and that makes us kind of dumb. You know, back in the 1970s, there was this push to convert to the metric system, and there was such pushback by people that it just didn't take hold. And it's unfortunate because every other country almost in the entire planet uses the metric system. Ah, it is so frustrating to me. Take a look at this map. Okay. This is crazy. This is crazy. This is a map of the world and the red countries. Now, this big red, that's Alaska and us. So this is just one. It's us and Liberia here. Okay. In the western coast of Africa. And then Myanmar, which is also known as Burma. We're the only ones still using this old archaic system. Everyone else uses the metric system primarily. It's just ridiculous. It's ridiculous. I can't even go there. It gets me so mad. So, section 3 is going to talk about analysis of different dimensions and things, and specifically talk about how we do some converting. So, you'll see on your notes there's an item like a vocabulary term for a conversion factor. And here's what a conversion factor is. It's a rate. We've talked about rates already. And you remember that a rate is a ratio that has different units. Yep, yep, yep. Okay. But the quantities are equal. Okay, now you're thinking to yourself, well, wait a minute. Units are different, but the quantities are equal. What on earth do you mean? Well, this is what I mean. There are some examples here, such as 12 inches and 1 foot. Okay, notice the numbers are different. The units are different, but these two values, in a sense, the quantity 12 inches as a distance and 1 foot are exactly the same. They're equal to each other. They look different because they're using a different unit, all right? But 12 inches is exactly equal to a foot. So in a sense, this really is the same as 1, even though it says 12 on top and 1 in the denominator. It's kind of weird, but it's because of the units that forces that. All right, here's another one. I love this one. 5,280 feet are in 1 mile. 5,280 feet are in 1 mile. See, here's the reason why I get so worked up about the customary system that we use in America is because you have to remember all of these bizarre numbers that you just have to memorize them. You know, who remembers 5,280? Who remembers 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile? Ugh, it's crazy. Really? You want to remember that a gallon is 4 quarts and a quart is 2 pints and a pint is 2 cups and a cup is 8 fluid ounces? You know, I have to like remember all these things myself. It's crazy. Here's another one. Oopsie. In time, 60 seconds for a minute. Now, I'll give you this. Time is a universal thing. There's not like a metric system for that. So that one is kind of stands alone by itself. But let's talk about something for the metric system then. So for example, if I have 1 kilometer, okay, so if I'm talking about distance or length, 1 kilometer is the same as 1,000 meters. Okay, if I have something like 1 liter, and I usually use capital L, but if we want to write this out, 1 liter is the same as 1,000 milliliters. Okay, or maybe I want to say something like maybe if I said something like this, 1 centimeter is the same as 10 millimeters. It's not always 1,000. I'm just not picking the best examples off the top of my head, okay? The nice thing about the metric system is everything is based on decimals. Everything is based on powers of 10, 10, 1,000, 100, 1/10, 100th, like that. And it just makes it so much easier. So today what we're going to do is focus just on the metric system. So I'm kind of doing this a little backwards, but your learning target for today then, okay, is I can, okay, and here we go. I can convert quantities within the metric system. Okay, I can convert quantities within the metric system. It's actually really straightforward and easy because our number system is based on tens. Our number system is based on powers of 10. And so really it becomes an exercise in understanding which way your decimals go. All right. Now, you should have a big old kind of, it looks like a set of stairs, really. Okay. That happens here. And so what we're going to do is start with the metric system like this, and I'm going to put it on stairs just so that we get the idea of up or down rather, but them right or left, but you'll understand why in a minute. So let me make sure I've got this plotted out right here. Okay, so at the bottom here, we are going to write kilo with a hyphen, okay? And then next comes hecta or hecto. Let's see, should I do hecta? Hect, acre, hecto. I think it's hecto. Next comes deca with a K. Deca with a K. Then on this level, I'm just going to say the word unit, and you'll understand why in a minute, the main unit. I'll even kind of put that in parentheses there. Then comes deci with a C, then centi, like cents, and up on top is milli. Now, the nice thing about the metric system is it works for all 3 kinds of measurement that we're talking about. It works for length or distance. It works for capacity or liquid. And it works for mass or weight. Okay, and use the same prefixes, and the units are just a little bit different. So under main unit here, I want you to think of for length, we use meter. Okay, so if I'm talking about meter, the meter would be on this step, and a meter is about, about from here to here, it's actually close to 39 inches long. So it's a little more than a yardstick. Okay, that's a meter. If I'm talking about capacity, we are talking about like liquid and volume kind of things. And so that becomes the liter. And our common frame of reference in the United States would be like a liter of liquid or a 2-liter jug of soda. Perhaps that's a common thing that you can relate to. Okay, so then liter would be on the main unit level, and then you could have decaliter, hectoliter, kiloliter, or deciliter, centiliter, milliliter. Okay, the last one is mass or weight, and that is a gram. And so you put that here where you could have decagram, hectogram, kilogram, decigram, centigram, milligram, like that. In fact, if you look at, if you have a headache and you want to take some acetaminophen or some ibuprofen for that, and you look at the pill or the medicine on the outside label, it'll usually tell you how many milligrams each capsule or tablet is. So we do use some of the metric system in our daily life. We just haven't totally converted or let go. Now, here's the beauty about all this. Okay, depending on where you start and where you're going. So today you're going to, for example, do some conversion between, let's say I have 1 kilometer, and I want to know how many, let's say, how many centimeters is that? All right, so here's what you do. Here's kilometer here, and you basically figure how many stages or steps do you have to go through to get to centimeters. You go 1, 2, 3, 4, 5 steps, okay? And basically what you have to do when you're going up the ladder, you multiply by 10 for every step that you take, okay? So if I'm going 1 kilometer and I realize I'm going to have to take that 1 and I'm going to have to go times 10 to get to the hecto, times another 10 gets me to deca, times another 10 would get me to the main meter, times another 10 is the deci, and times that next 10 is centi. Notice that this is 10 to the 1, 2, 3, 4. This is 1 times 10 to the 5th power, which that's easy to do because that just simply gives us 100,000. Okay, notice something. When I started at the 1, take a look at where my decimal point would have been at just 1, and then I went 1, 2, 3, 4, 5 places to the right. So when I look at it this way, if you kind of tilt your head, you're thinking going up the ladder is the same as going to the right, that many decimal places. Nice. All right. Let's say I had something like, let's make up another example here. How about this one? What if I said I have 247 centigrams, and I want to know how many decagrams that is. Now, notice you have deci and deca. So usually we'll put the dk for deca, and sometimes they'll just use D or they'll write DC for the abbreviation for deci, so you can tell the difference. Okay, so I'm starting with centigrams. I'm up here. This time I have to travel down the stairs. So I have to go down 1, 2, I'm going down 3 steps. When you travel downward, or if you're looking at it sideways and you're going to the left, you are really dividing by 10 for each step that you're taking. Okay, so I'm starting at centi, and I have to go down 1 step, that's dividing by 10, down another step to the main unit, down another step to this unit. So you're dividing by 10 3 times. Okay, so I'm taking 247, and really I'm dividing by 10, and then I'm going to divide by 10 again and divide by 10 again. Or in other words, you kind of think of it this way. You could kind of think, well, taking 247 divided by 10 and 10 again and 10 again. And when I put them in the denominator, it's kind of like you're multiplying them all together. They're ganging up down there. All right. Or you think of it this way. I go boom, boom, boom. It's like moving your decimal point 3 places to the left. you get 0.247. Do it on your calculator. Take 247, divide by 10. That first step would give you 24.7. Divide by 10 again, you'd get 2.47. Divide by 10 again, you get 0.247. Okay, so really, oh my stars, isn't the metric system so easy? If you go up the ladder, you multiply. Come down the ladder, you divide. Or look at it this way, a little tilted with your head. When I'm going up, that's like moving your decimal point to the right or moving it to the left. You can, if you get that, you can go from there and just simply slide, slide, slide. So your first assignment today is going to be converting all these different measurements within the metric system on this worksheet. Let's take a look at this first one. 10,000 meters is how many kilometers? 10,000 meters, let's go back and look here. Meters, that means you'd be on this level. How many, whoopsies, how many kilometers is that? So you're going from the main unit to kilometers. You're going down 1, 2, 3. Divide by 10, divide by 10, divide by 10. Okay, so go ahead and either do it on your calculator or think, I'm going to go to the left 1, 2, 3 decimal places. That means 1, 2, 3 decimal places. You should get exactly 10. Get out of town. It's that easy. Yes, the metric system is brilliant. And if we would just do away with the whole customary imperial system, we would just be so much better off. Seriously, so much better off. All right, so your assignment, you keep your chart out so you get used to it, and we'll go from here. Get this worksheet under your belt, and as always, may the force be with you.